Hey there. We're going to dive right into day 2 of Advent of Code 2022. I'd like to try to solve these puzzles in about an hour using our programming language, and my approach is to make these videos as well aimed at novices like myself. So let's go ahead and dive right into it. Day 2, rock, paper, scissors. The elves begin to set up camp on the beach. To decide where the tent gets to be closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between two players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors during the handshake. Then, a winner for that round is selected. The rock defeats scissors, scissors defeats paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide. That's going to be our puzzle input. That they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, C for scissors. The second column, suddenly the elf is called away to help with someone's turn. The second column, you reason, must be what you should play in response. X for rock, Y for paper, Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score of a single round is the score for the shape you selected. 1 for rock, 2 for paper, 3 for scissors, plus the score for the outcome of the round. 0 if you lost, 3 if you draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. We'll go through the example in a bit. This strategy guide predicts and recommends the following. In the first round, your opponent chooses rock, denoted by the letter A. You should choose paper, denoted by the letter Y. This ends in a win for you with a score of 8. 2 because you chose paper and 6 because you won. In the second round, your opponent will choose paper, B. You should choose rock, X. This ends in a loss for you with a score of 1 because you chose rock, and the 0 comes because you lost. Remember, in this scenario, you're not supposed to win every single round of rock, paper, scissors. In the third round is a draw because both players choosing scissors, giving you a score of 3. First 3 because you chose scissors, second 3 because you have a draw. In this example, if you follow the strategy guide, you would get a total score of 15 from those 3 rounds. What would the total score be if everything goes exactly according to the strategy guide? Here we go. This is slightly complicated, at least the way I'm drafting it in my mind. So during this hour, I'm going to walk us through it. I'm going to make myself a script file in RStudio. That's a new Quartal document. We have, I'm going to call this one 2022 December 2nd, Quartal Markdown QMD. And just as my old habit, I'd like to keep the puzzle right next to the code. Okay. Now, these 3 rounds with the ABC, XYZ in some order, that's going to be my puzzle example. I'm going to put that in there. R likes to have the extra line at the end. And then I'm going to collect the input as well. There are better ways to do this, but again, I'm making these videos aimed for us novices to understand what's going on. Namely, we're going to need to bring in both the example and the input somehow. So in my session, when I click on the puzzle input button, I'm going to get all this here. I'm going to select all, copy, bring it to here, make sure I have an extra line at the end. Good. And we'll see how this goes. Part of the hassles or the for already going is you got to understand your programming language and how it brings everything in. So I'm going to start off by saying that the raw data comes from reading the lines of my example file, which was a text file. So now in the lower left hand corner, I show you that data raw looks like that. It has these 3 groups of characters, and we observe that in each group it's a letter, space, letter. I'd like to keep a count of how many entries we have. So I'm going to let capital N be the length of that data raw, and that should be 3 in this case. You can see that in the upper right hand corner. And in the R programming language, I like to store the information into a data frame. So I think what I'll do is I'll call one column opponent play, and we're just going to leave a bunch of blanks for now. R play, what we do in the rock, paper, scissors, but again, we're going to leave that blank for now. And I'm going to add more to the data frame in just a bit, but I'll show you that later. I just want to show you right now what the data frame looks like. I want to eventually get the letters from the example, that A, B, C, X, Y, Z in here, as also is stated on the, whoops, these should be equal signs, as was stated on the website. So we're going to load the data into the data frame. The first part was loading data. Going to do a giant for loop. I'm going to take each of these here, the A, Y, B, X, C, Z, going to grab one of them at a time. Like so. And then from there, I'm going to take the first letter. Well, first I want to separate these. So what I'm going to do is from the string R package, there's a string split function, and I'm going to split these by that space. So let me run this code once. Whoops. An error appeared. I might not have used the string split code correctly, so let me do a couple things. First, just to make my life easier, I'm going to load into tidyverse. then later on when I post this on GitHub, I just want the extra messages and warnings not to appear in that particular spot. Sorry about that. Okay, so for the string split function, instead of a separator, we call this a pattern. So I don't need that. Okay. So at the moment, our data raw, if you look in the lower left-hand corner, our data raw looks like this. I'm going line by line. This line now looks like this. So you can see that I've separated, once it got down to the end, I separated the C and the Z. That's what I wanted to do. Long story short, this is a nested list. So it turns out each time I run through the for loop, I only want to get the first element of the nested list. So we tacked on. From here, our opponent play in that row. Actually, I haven't done that in a while. Let's call this row. It just makes so much more sense, doesn't it? Our opponent play in that row is this line and the first letter from this line. Similarly, our play in that row is this line, but the second letter. So now, when we look at the data frame, nope. Something went wrong. I forgot to name the data frame. Sorry about that. Now we have the ABC, XYZ as presented in the example in the places where I wanted it. We saw in the puzzle that the score incorporates the shape you selected, 1 for rock, 2 for paper, and 3 for scissors. So what we're going to do is take that second column, the X, Y's, and Z's, and simply translate that into the scores, the 1, 2s, and 3s. And I think what I'll do is start a new code block here. So what I want is a new column. I'm going to use a mutate command here. I want a new column. I'm going to call this rplay score, and that is a case when. So when our play is just double checking my thought process. When our play is X, that means our play score will be 1 point. When our play is Y for paper, let me rock paper. When our play is Y, we're going to get 2 points. When our play is Z, we're going to get 3 points for scissors. In the code, you want to have like a catch-all here in a case when statement. I'm going to assign that 0 points, but I'm going to do a side note. Hopefully it never takes effect. I'm just doing that for proper coding. So now looking at our data frame, we get the 2 points for playing paper, the 1 point for playing rock, and the 3 points for playing scissors. Now for the hard part. With that in play, let's see here. We're going to have the outcome score. That is when paper defeats rock, when scissors defeats paper, etc. So when opponent play double equals A for rock, and our play double equals X for rock, a tie is 3 points. If you're actually watching a YouTube video, you can probably skip ahead by about a minute. I think there are 9 outcomes. I'm going to put a -1 here. Actually, I'm going to put a really ridiculous number, -99 here. If the code gets down here, something went wrong, but I want to know that something went wrong. Okay, so the opponent could play A for rock, B for papers, or C for scissors. We could play X for rock, Y for paper, Z for scissors. Rock, rock, a tie is 3. I really should double check this. Zero points if we lose, 3 points if it's a draw, 6 if we win. Okay. So again, rock, rock, 3 points for tie. Rock, scissors, 6 points for win. Rock, oh sorry, that was rock, paper, rock, scissors, 0 points for loss. So we're going to need these numbers 3, 6, 0 in the next spots as well, but in a different order. Paper, rock means we lost. Paper, paper means we tied. Paper, scissors means we won. Scissors, rock means we won. Scissors, paper means we lost. Scissors, scissors means we tied. I'm going to run this actually from the start just to make sure my code works well. I forgot the double equals on the second set of conditionals. So now, you notice in the data frame, let me bring up the story again. In the first round, opponent chose rock, we chose paper. 2 points for paper, 6 points because we won. Second round, opponent chose paper, we chose rock. 1 point for rock, 0 points for loss. In the third round, we both chose scissors. 3 points for scissors, 3 points for tie. Now let's go ahead and add them up. So there will be another total, let's call this round score, maybe. equal to our play score plus our outcome score. I'm gonna run it from the beginning. So now that the last column has the 8, 1, and 6 points as the example implied, and now we print this next part is relatively easy. I just like to be really explanatory here. The total score from all plays is, we're going to print the sum in that last column. And that should be the 15, which is what we get here in the example. So now that my code plays through the example correctly, let me load up the puzzle input instead. Run that. Our puzzle input, by the way, had 2,500 matches of rock, paper, scissors. So the computer code should be able to go through all 2,500 matches, keep track of what we played, assign a score, keep track of what the opponent played, what we played, assign a score, add those up, and then finally add up everything. The total score in my session here was over 12,000, and that's not the right answer. Uh-oh. Okay, looks like it's debugging time. For one thing, I just want to make sure I never got to negative 99. I wonder what I would need to check. Let me check the outcomes. So it looks like the outcomes, at least as far as possible numbers, seems to be okay. I wonder what went wrong. Let me run through the score plays again. Or refresh the data table, I should say. Let me double check our play score while we're here. Our play score, apparently we played rock 517 times, paper 582 times, and scissors 1,401 times. The outcome score, we had a draw 657 times. Sorry, lost 657 times, a draw 1,580 times, and a win 263 times. Just want to double check this. That we do have all 2,500 there. Let me look at the first few rounds. Opponent plays scissors. We played rock. 1 point for rock. might have just switched it right at the very end there. Okay, in the second round, opponent plays rock. We played paper. 2 points for playing paper, 6 points for win. Third round, opponent plays scissors. We played scissors. 3 points for choosing scissors, 3 points for tie. Okay. I might have... Oh. Yeah, it's literally this line of code that I messed up on. Opponent plays scissors. We play rock. This should be 6 points. Okay. That is, the 360 should be used each 3 times. I mentioned that earlier and I forgot to check myself. So let me go ahead and run this code. Whew. Good thing, because I actually failed to give myself some points earlier. And that's the right answer. Give ourselves a pat on the back. Boom, boom. Let's move on to part 2. The elf finishes helping with the tent and sneaks over back to you. Anyways, the second column says how the round needs to end. Oh no. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. The total score is still calculated the same way, but you need to figure out what shape to choose so the round ends as indicated. Let's go back to the example before I forget. And we'll do a part 2 here. What I'm going to do is put the example on the left side so you can see it. Okay. In the first round, this AY here on the left, your opponent will choose rock. You need to end the round in a draw. Therefore, you need to also choose rock. This gives you a score of 1 plus 3 is 4. In the second round, the BX, your opponent will choose paper. You will choose rock so that you will lose. X meaning lose this time, not rock. Your score will be 1 plus 0 is 1. In the third round, you will defeat your opponent's scissors with rock. Z meaning win. So 1 plus 6 is 7. Now that you're correctly decrypting the ultra top secret strategy guide, you'll get a total score of 12. Funny thing is, I don't think I have to change that much code, Derek says cautiously. I think what I'll do is actually copy all the code below part 2. If anybody is actually reading this later, then they'll be able to see what I was doing. Okay. So right now for part 2 of all the instructions I just said, I'm loading in the example, loading it to a data frame, and it looks like that. Instead of our play, we're going to call this strategy. So X means we're going to want to lose, Y means we're going to want to tie, Z means we're going to want to win. Now, at first it sounded, what I was worried about was it sounded like with that in mind, we got to then keep track of when to play rock, when to play scissors, when to play paper. But I think we could just go ahead and skip ahead and figure this out on our own. So when the opponent plays rock, actually, yeah, I think all we need is the second column, isn't it? Okay, I'm going to take a big risk here. I think all we need is these. So when we're asked to lose, we score 0. When we get asked to tie, we score 3. And when we asked to win, we score 6. Is that all right? So I got something wrong at the moment. Let's track it down. In the first round, opponent plays rock. You'll need to end the match in a draw. Oh, yeah, I got too far ahead of myself. Okay. Sorry about that, folks. Let me fix that. Yeah, that was way too easy for part 2. I don't know what I was thinking. So what I'm going to do is we're going to look for the outcome score first. Okay. So the outcome score this time around is still based on our play. I actually should not have deleted that. So when it's X, we're going to be asked to lose. When it's Y, we're going to be asked to draw, to tie. And when it's Z, that's when we win. It's our play score that changes. Okay, that's what I wanted. And I called this strategy. I keep forgetting to switch that. When the strategy says X, we lose. When the strategy says Y, we tie. When the strategy says Z, we win. There's a faster way to paste. I just never learned it. Okay. So when the opponent plays rock and we're asked to lose, we're playing scissors, and we'll still get 3 points out of that for playing scissors. When the opponent plays rock and we're asked to tie, we're playing rock, and that gets us 1 point. When the opponent plays rock and we're asked to win, that means we're playing paper and we get 2 points. I'm going to need these 3, 1, 2s in some order down here. When the opponent plays paper, we're asked to lose. That means we'll play rock and we lose. When the opponent plays paper and we're asked to tie, that means we're playing paper, we get 2 points. When the opponent plays paper and we're asked to win, that means we play scissors, we get 3 points. When the opponent plays scissors, when we're asked to lose, that means we're playing paper. When the opponent plays scissors, we're asked to tie, we're playing scissors, that's 3 points. When opponent plays scissors who has to win, that means we're playing rock, that's 1 point. Okay. I forgot a comma. Now, the example says I should have ended up with 12 points, and that's the 12 here. Okay, so now that my code does the example correctly, I'm going to run through the input. 2,500 matches, once again. My score this time was the elf strategy guide. Boom! We solved it. Alright folks, if anybody's watching this, I hope it was useful. Code's going to be online as well. And I guess I will see you tomorrow. Bye.